sklearnmanifold trustworthiness. Description: explain in detail. Trustworthiness is a metric used to evaluate the quality of a manifold learning embedding. It measures how well the embedding preserves the local neighborhood structure of the original data. A higher trustworthiness score indicates that the embedding is more faithful to the original data's local structure. Inputs. Input 1. Explain in detail. The input data represented is a 2D NumPy array where each row represents a data point and each column represents a feature. Input 2. Explain in detail. The output embedding of the manifold learning algorithm, also represented as a 2D NumPy array. Each row corresponds to a data point in the input data, and each column represents a dimension in the embedding space. Outputs. Output 1. Explain in detail. A single numerical value representing the trustworthiness score of a embedding. The score ranges from 0 to 1, with 1 indicating perfect preservation of the local neighborhood structure. Steps. Step 1. Explain in detail for each data point in the original data. Find its k-nearest neighbors KNN based on the original data's distance metric. Step 2. Explain in detail for each data point in the embedding space. Find its k-nearest neighbors KNN based on the embedding space's distance metric. Step 3. Explain in detail. Compare the KNN sets in the original space and the embedding space. A higher trustworthiness score indicates a greater overlap between these KNN sets. Metrics. Metric 1. Explain in detail. Trustworthiness is itself a metric used to assess the quality of a embedding. Metric 2. Explain in detail. Other metrics such as continuity, stress, correlation can also be used to evaluate the quality of the embedding. Visualization plots. Visualization plot 1. Explain in detail. Scatter plots can visualize the original data and a embedding to visually inspect the preservation of local structures. Visualization plot 2. Explain in detail. Heat maps can be used to show the trustworthiness scores for different values of k, the number of nearest neighbors. Fine-tune parameters. Parameter 1. Explain in detail k, the number of nearest neighbors considered when calculating trustworthiness. Parameter 2. Explain in detail n neighbors, the number of nearest neighbors used in the manifold learning algorithm. This parameter influences the local neighborhood structure and can impact trustworthiness. Uncertainty methods. Uncertainty method 1. Explain in detail. Bootstrapping. Repeatedly resample the data with replacement and calculate trustworthiness on each resampled dataset. The variability in trustworthiness scores across these samples can be used to assess uncertainty. Uncertainty method 2. Explain in detail. Cross-validation. Split the data into folds and calculate trustworthiness on each fold. The variance in trustworthiness scores across folds can be used to estimate uncertainty. Challenges and fixes. Challenge 1. Explain in detail. High dimensionality trustworthiness may be sensitive to the curse of dimensionality, where distances between data points become less meaningful in high-dimensional spaces. This can lead to unreliable or inaccurate trustworthiness scores. When working with image data with a large number of pixels, the trustworthiness score may be inaccurate due to the high dimensionality. Dimensionality reduction techniques. Apply dimensionality reduction techniques like PCA, TSNA, or UMAP to reduce the dimensionality of the data before calculating trustworthiness. This can mitigate the impact of high dimensionality and improve the accuracy of the score. Challenge 2. Explain in detail. Nonlinear data trustworthiness may not be effective in evaluating the quality of embeddings for highly nonlinear data. The linear assumption underlying trustworthiness might not accurately capture the underlying structure of the data. When using manifold learning to embed data with complex Nonlinear relationships. The trustworthiness score may not accurately reflect the quality of the embedding. Consider alternative metrics for highly nonlinear data. Consider using other metrics like continuity, stress, or correlation to evaluate the quality of the embedding. These metrics may be better suited to capturing nonlinear relationships.